I'm going to use this for a cycle cart. They normally come with a disc brake attached, which gives me a useful attachment point to build a hub. The hub will use a 25mm keyed axle to go through and bolt on, but it will pick up the drive from the four bolts that hold the disc on. So we'll be machining up a hub to support this from a piece of aluminium billet. That will bolt on there, and I can, if I want to have the brakes on the wheels, I can put the discs on and the axle will go through the centre. So I'm just measuring up the sizes required to machine this down. So it needs to be 95 outside diameter, and we're seeing about 58mm inner diameter. With 4 mounting holes in it. I can either do a direct drive from this block onto the axle via a keyway, or I can use one of my freewheels. These are the freewheels I use for drive axles for low powered vehicles. So if this is the axle turning here, it would drive the hub forward in that direction, but freewheels the opposite direction. So the drive is that way, freewheels that way. The motor will always be turning that way because there's no reverse on this at all. So. And then on the opposite side, this would work on the left hand side of the cart. If that's forward, it would go that way. But the problem being, if you fitted it that way round, the opposite direction, on the right hand side, you'd be trying to unscrew this hub out from the freewheel. So what I need to do is, on the right hand side, that part is swapped over to the other side, so that it's still screwing in the direction of a right hand thread tightening. So basically that hub there that this is bolted to is flipped the other way. Well, it's threaded to anyway. There's a 1.375 inch by 24 threads per inch thread on that drive adapter, which is then keyed onto the shaft. And then on the other end I can put in a couple of bearings in there as well, and a nut on the end will give extra security of holding the wheel on. But the main drive will be through the 4 bolts that will run right through. So I shall mount this up in the chuck and start to machine it. Right, I've got a billet, it's about 4.5 inch diameter. Turn it down a bit. They're not perfectly circular, and certainly not square cut on the bandsaws, so you need to do a bit of initial machining on them to get them anything like round. includes the machining on the lathe anyway, of that part. Next thing to do is put the rotary table underneath the mill head here and put in four, I'll probably put in 8 tapped holes there, because I need 4 to mount the hub onto the wheel, and I need 4 to mount the freewheel onto this. So that's a bit smaller than it was, a lot lighter, and freewheel can slip in there. Honest, it fits. Anyway, I'm saying there'll be 4 holes drilled in there for M8 bolts that will hold the freewheel to give the drive to this hub, and then in the centre will be a threaded boss that will attach to the axle, and then there'll also be, let me get this back out here, there'll be 4 recessed holes in here where I can put bolts into the hub itself. I've got my rotary table mounted and I've set it up for drilling the first set of 4 holes. These are on a 78mm PCD. So I'll just put a pilot hole in to start with and then take them out to 8mm clearance, and then I can do the other 4 holes which are on a slightly different PCD. Well, I'll take the small bearings out, get the oil seals out, the oil seal, the other oil seal. Quite difficult to knock the bearings out, but to catch an edge of the inner sleeve and then knock the opposing bearing, quite difficult to get hold of it. That's it. That's the sleeve, that's the bearing. And just pop this one out. Might hit my fingers. Starting to move. That's it. So I'll just clean that up. There is a step on this face here, and it tapers as well. So the new spacers I've got for the 20mm shafts, I put a taper on them, but I will need to relieve it somewhat on this face so that it can come through and hit the inside edge of the bearing, and the race of the bearing. So that end needs to rest against the inner race. But, there's a lip there that's too big, so what I'll do is I'll go in with a cone drill on this side and take that lip off, and then I need to relieve it slightly more with the aid of a die grinder. Clean up the bearing faces and put the bearings in, not forgetting to put the spacer in. So, here's my drill. lip removed. Just need to get a bit more clearance on it. About. Right, I think I'll go and machine a wee bit more off the sleeve. Okay, machine the sleeve, a bit more taper on it. It now fits through. So, it's a case of sticking the bearings in. There's the bearing. Started in there. I'll just use an old bearing to knock it in. Should work. Sounds like it's seated in. Yep. Turn it round the other way. That's a swarf. I'll get it square. Right, it's in and it goes around. Won't be needing the seals. We've got double rubber sealed bearings. The ones that came out were only sealed on one side. The inside hasn't got a seal. Or was it? Got the 20mm bearings fitted to this wheel. There's a 46mm long sleeve that bridges between the two bearings so that you don't crush them down when you tighten the bolt up. What I'm going to do is machine this axle. I'm going to tap the end of it. I'm going to tap that 1/2 inch UNF or 12mm, probably 1/2 inch UNF. That will have the bolt that will secure a 1 inch washer that will bear on the inner race there just to hold the wheel on, or as a little bit extra security. And then this will be machined down to 20mm diameter for about that long. That'll be about the point of the end of the outer bearing, and then the outer bearing will sit on there, on that shoulder. And then this is the hub that bolts the wheel on and has the freewheel device and the axle adapter. Stuck in that. I'm sure it'll come out. Yep. So there's two sets of holes there. This outer set of holes is for securing the teeth that stop it rotating. So little stainless bolts screw in there and hold that on, and then the pocketed holes take these bolts that screw it to the back of the hub. See the back there, there are 4 tapped holes that would originally hold on the disc rotor. They will still hold the disc rotor on, but they'll be sandwiched between that. You can see that. Disc rotors sit on there. I've got the 25mm axle in my lathe so that I can put in the bore in the end to tap for the retaining bolt, and then I'll machine this down to 20mm for the bearings. But being such a long shaft, it's going to vibrate something terrible. As you can see, now to cure that, I'm just going to fit a bearing and mount it on the platen for the drill, and that should stabilise that wobble. Where's my bearing gone? Here it is. Just a 25mm self-centering bearing. Should slip on. I'll just put a clamp on it. It's just a wee fraction low there. I'll jack the table up and then clamp it and see how it goes. Right, clamp a bearing on there, see how that works. There we are, that's a lot better. Right, found an 11.5mm drill. Need to use the adapter for the more staplers. Half-inch UNF. Right, I'll keep tapping that until I get down to the depth I need. Right, that's the end tapped for the 1/2-inch UNF bolt. The next thing to do is to machine a 46mm long section down to 20mm. It's probably got a very slight interrupted cut where that keyway is. That's a washer. That keyway is probably down round about 19mm. Right, I need to extend this a bit further out because that's not 66mm. So I've machined it down. As you can see, there's still a little flat of the witness for the key that was there. Let's turned it down and polished it up so that the bearings slip on quite nicely. That should be fine. Just need to check my length to that face, make sure I've got the 66mm I'm looking for. That's one side done. Spinning quite nicely. Got a slight problem with the opposite wheel. It's going tight when I put it in the bearings, so I think I've got the centre sleeve a bit tight in the hub that's binding up. So I need to check the sizes and the clearance in this other one. This one here, so it's locking up when I put the bolt in the end, so I think the centre sleeve must be the wrong dimension that's binding things up. I shall need to pull the bearings on that one and have a look at it. So I changed the bearing spacer in the centre, and that seems to have done the trick. Now it now spins freely. That's the axle completed. The only thing that needs to be put on it is the sprocket carrier, which will sit at some point to suit the engine. This support bearing for the sprocket end can slide back and forward to support where it's required. It should be right next to where the sprocket carrier sits. That's dictated by where the chain line is on the engine. The bearings can bolt to the underside of the chassis rails or the top side of the chassis rails, or I could change them out for side mounted. There's a collar on there on each side just to make sure the key doesn't back out, or the key is locked with a grub screw that's accessed via the little holes if necessary. To take the wheels off, these 4 bolts need to come out, and then the bolt on the end of the axle comes out, and the wheel then slides off, leaving the freewheel in place on the axle. It's locked to the axle, and there's a key in there as well. Same on this side. This is the left hand side of the car. The freewheels mounted the opposite way round on each side. So this one the adapter sticks out on the inside, and this one the adapter's inside the hub itself. And that way the axle can drive forward by rotating that way, and it freewheels going the opposite direction. When the axle is driving forward, both wheels go forward at the same rate. It's almost like a locked axle, but when you corner, one wheel can lag behind the other, so it can pivot. So it's more like a differential in that respect. The only thing with this is you can't reverse it. If you try and reverse, the axle freewheels. If you try to drive in reverse, the axle freewheels, but if you try and push the car back, the axles will actually turn and try and turn the engine backwards, so you need to watch out for that. got 275 17 tyres on here, on these 1.4 inch wide Honda ANF125 front wheels. Got the disc brakes on there. You need to have 2 disc brakes because of the way the axle works. If you just had 1 disc brake, the car wouldn't stop. These are the calipers I'll use. I think these ones actually came off a quad, but they just go on like that and then make up a suitable bracket to mount off the chassis. It is pretty rigid, there's no wobble in the bearings. There's quite a lot of support. It's not just supported off these 4 bolts, it's bearing on a pair of bearings inside the hub itself, and the stub, the 66mm stub that sticks out, is a good fit on the bearings, and then this nut on the end secures the bearings to stop it coming off if anything slackens off from the other side. So next thing is to make a sprocket carrier and get a suitable sprocket made up for the engine I'm going to use, and obviously build a chassis to mount it to. I think the dimension from centre of wheel to centre of wheel is 37.5. I think that's what I calculated it should be, not measured that. See if we can measure that. Give me a second. And the answer is 37.5. Yep, 37.5, just what I calculated. For Cyclekarts, the nominal track width has been specified at 38 inches, so 37.5 is not bad. There it is overall, rough guide. Yeah, roughly 41 inches overall over the tyre. That turned out very nicely, say so myself. Well, we're needing rain.